Welcome to kickoff weekend for Polar DinoFest, a 10-week exploration into the world of polar dinosaurs. My name is Randy Ermis. I am the Chief Curator and Curator of Paleontology at the Natural History Museum of Utah, and I'm coming to you live from the Paleontological Collections. To kick off our virtual festival, we are continuing our live stream panel today to introduce our 12 Polar DinoFest paleontologists. This is our second panel of the day and will be live again at 5 p.m. Mountain Time with keynote speaker, Dr. Peter Makovic. These live conversations are just the beginning of 10 weeks of polar dinosaur exploration online as we release a new video from each of our guest paleontologists each Friday at 10 a.m. between now and April 2nd. You can see the complete schedule of our live conversations, watch the recorded panels, and find all the video release dates for our speakers' full videos on our website at nhmu.utah.edu/DinoFest. And if you want to participate in these live conversations, we encourage you to submit your questions now via the webpage, our Facebook account, or YouTube channel. Now, I'm delighted to introduce you to our guests. I'm joined virtually by two fellow paleontologists. Dr. Jaelyn Eberle is the director of the Museum and Field Studies program and curator of fossil vertebrates at the University of Colorado Museum of Natural History and a professor in the Department of Geological Sciences at the University of Colorado Boulder. How are you, Jaelyn?
I'm doing well, thank you, Randy.
And we're also joined by Dr. Ron Tykoski, the Director of Paleontology and Curator of Vertebrate Paleontology at the Perot Museum of Nature and Science in Dallas, Texas. Hi there, Ron.
Hi, Randy. How you doing?
Good. Thank you so much for joining us this afternoon.
Glad to be here. Thanks.
So both of you, of course, are vertebrate paleontologists and have worked in the polar regions. So I want to start out just by finding out a bit more about your research. Jaelyn, could you tell us a bit more about what you work on?
Sure. So I know that the title of DinoFest, or the focus, is polar dinosaurs, but I actually work on Arctic mammals. So I don't work on dinosaurs, but most of my field research occurs in the Canadian high Arctic on islands such as Ellesmere Island, Axel Heiberg Island, which are up close to Greenland, actually. So I'm working close to northern Greenland, but on the Canadian side. And then I also work on fossil mammals. They're a little bit older and overlap with dinosaurs up on the north slope of Alaska. So, so my focus is fossil mammals, both before and after dinosaur extinction.
Awesome. And how did you get into Arctic mammals in the first place?
Well, so, you know, I grew up in Canada. I'm from Saskatchewan. I grew up on a grain farm in southeastern Saskatchewan. And as a kid, I just loved fossils. I remember my grandmother taking me out on the land and we would just be looking for fossils ever since I was, I don't know, 3, 4 years old, maybe. So we were always on the land and always looking for fossils. And I do even remember as a younger individual hearing about fossils from the Canadian Arctic. And I just remember by the time I hit college, I said, that's where I'm going to work. You know, I'm Canadian. It's in the Canadian Arctic. I'm going to the Arctic. That's it. And so I got my undergraduate degree in Saskatchewan, came down to the States for my PhD, University of Wyoming. But one of my advisors in Canada at the University of Saskatchewan was a paleobotanist that did lots of Arctic work. And he told me, he said, before I left, he said, you know, Jaelyn, when you get your PhD, I'll take you to the north. And he kept his word. And so I got started in the late 90s and I have been going back since.
That is super cool. Oh, awesome. And Ron, I see a big fossil something behind you. So could you tell us a bit about your specialty in paleontology?
Well, I've actually kind of gotten to Arctic paleontology and Arctic dinosaurs in a roundabout kind of way. I started out my work more interested in things in the late Triassic and early Jurassic, but this guy, a couple of guys, one of them named Randy Ermis, kept finding more Triassic things and kept turning my work upside down. So I guess I needed a different distraction. So after I started as a fossil preparator at here in Dallas at what would go on to be the Perot Museum, and turns out the timing was just such that as I was arriving, a huge influx of Arctic dinosaur material was arriving here that needed a lot of fossil preparation. And as an anatomist, systematist, and fossil preparator, you start working and learning and getting really familiar with these things. And so supporting the work of Tony Fiorillo, who was going out and doing this stuff, collecting these specimens in the North Slope and places like that, through guilt by association, I wound up actually learning quite a bit about these Arctic dinosaurs, and lo and behold, helped make some interesting discoveries up there. And yeah, that is one of them there. That, as you pointed out, that's one of our skulls of Pachyrhinosaurus burroworum from the North Slope of Alaska.
Well, I'm going to invoke host privilege and ask a follow-up question, because you mentioned something I think that's not always appreciated, which is that as a fossil preparator, you often really get to know the fossil in a lot of detail because you spend so much time with it. And I think, a lot of people don't realize we only really get to see a lot of the fossils back in the lab for the first time. Could you tell us a bit more about that?
Yeah, usually when something arrives, it's usually in a horrible condition, especially like quarry that thing came from. Just a complete mess. But yeah, it's always neat when you're a fossil preparator. You actually sometimes are the very first human being in history to see something new for the first time. And that's really one of the most amazing and fulfilling parts of doing that part of paleontology, is that realization as you're uncovering some fragment of something that's been entombed for 70 million years, and suddenly you're the first one, And then then you can call a curator over and say, hey, guess what I found? Come on over. Guess what? You're the second person to see that thing, but I'm first.
Very cool. Well, and Jaelyn, we were talking before we went live that some of the methods you use to find your mammal fossils, particularly the really small one, are a bit different than what we use for big dinosaurs. Could you tell us a bit more about that?
Sure. Yeah, I think some of the techniques we use are things that you might see used by archaeologists. That's certainly where I initially saw these. But we'll often use screens, good sized screens. We'll collect sediment from a fossil site, and then we'll just dump that sediment into the screen and use a little bit of water and screen wash it, basically. So in a sense, Randy, we are washing dirt. Many people will ask me, is that what you're doing? And I said, yes, that is what we're doing, but we are ideally high grading those little tiny fossils that are occurring in there. So because a lot of the fossils that I work on from the North Slope, the little mammals that I'm working on, we're talking about teeth that might be 1.5 millimeters long, and a whole jaw might be 1 centimeter. So they're super tiny. So they're not things you're going to be, if you're prospecting, walking around, looking at the ground, even crawling on the ground, you're probably not going to spot. Trying to spot 1.5 millimeter tooth is probably not going to happen. We're going to have to get it usually through what we call in the wash, through the screen wash. And then we sort it. So once it's been screen washed and dried, we then take that sediment, and we have a host of sorters at the University of Colorado, and they sort it under a microscope, which is pretty time consuming.
Cool. And you mentioned that in addition to your Cretaceous mammals from Alaska, you also have worked in the Canadian Arctic, but that's from the Eocene, so that's after about 15, 20 million years after the time of dinosaurs. And are in the Eocene in the Canadian Arctic, are all those mammal fossils small as well?
That's a great question, Randy. No, they're not. You do get small ones. So we get rodents, which tend to be relatively small. Some of the primate cousins are fairly small. But then we get these great big lumbering guys like Coryphodon, which would have looked like a hippo. It's a hippo-like mammal. It's not a hippo. It belongs to an extinct group called the Pantodonts. But it would have looked like a hippo. And so certainly like a jaw of a Coryphodon could be, 1 foot or more in size. And those we would find in the Canadian Arctic the usual way, going along, prospecting, looking at the ground. But we still bring back sediment from the Canadian Arctic to sort, because that's how you're going to get your rodent teeth, teeth that are maybe the size of a mouse tooth. So you kind of do a little bit of both in that case. You got big guys, you got little guys, and then you have some medium ones. I work on tapirs as well, and we have tapirs in the Canadian Arctic, and they're kind of maybe a medium dog-sized mammal that we had up there in the early Eocene. So usually we can spot their fossils as we're prospecting, but if we're lucky. So
I think, I mean, a lot of people think about the Canadian Arctic as this really cold, desolate place, but you're telling me about things like primates and tapirs and Coryphodon, which we find here in Utah as well.
you do.
So how are all these like, mammals that we think of as being, you know, in some cases tropical mammals today, how are they surviving in the Arctic?
Well, I think the main thing to keep in mind about the Eocene Arctic, and by Eocene, what I'm talking about, we think these fossils were about 52 to 53 million years old, based on the fossils themselves, but also there's a radiometric age up there now too, to give us a date. But so they're early Eocene, and during the early Eocene, the Earth was just warmer than it is today, certainly. Like, it was the height of global warmth since the extinction of the dinosaurs. So even places like the Arctic were a bit warmer, but well, quite a bit warmer actually than they are today. But they're still not what I'd call hot and tropical or anything like that. I mean, you were still probably getting near freezing temperatures in the winter and going upwards of maybe 20 to 25 degrees C. So maybe in your 70-degree Fahrenheit range in summer. But what we have learned through looking at the paleoclimate up there, using a variety of geochemical techniques to try and estimate temperature, for example, is that we had a much narrower range of mean annual range of temperature. Like the range of the temperature just wasn't as great back then as it is today. So certainly there was that. And then something that I think people are always shocked at when I mention to them is that when you go to during the early Eocene, the Arctic was blanketed in forest.
Whoa.
So we have fossil forests, and beautiful fossil forests with tree trunks sticking out of coal seams. So we know there were forests. So it wasn't as though these animals were living on the tundra. You didn't have tapirs on the tundra. You had tapirs in lowland forests. These were swampy forests. You know, these forests where we find the tree trunks are in massive, thick coal seams. So we had swamps and forests, mild winters.
That is,
you know, kind of.
It's just crazy. What a lost world. And so, Ron, the Cretaceous of Alaska, was it warm in the same way Jaelyn was just describing for the Eocene?
Yeah, absolutely. Again, much like what she was describing, there are areas up there where we find lots of fossil plants, trees. It looks like it was sort of a, you know, again, like she was somewhat describing there, it sometimes got cold enough to freeze. And these animals that lived above the Arctic Circle, they dealt with prolonged periods of darkness in the winter, long periods of light in the summer. So that light regime was what you see today, but it was a lot warmer. So you're talking about an area that probably had a climate a bit more like you'd find on the northwest coast of North America today, like around, say, Vancouver, Seattle, Portland, places like that. And also pretty wet and rainy. There's ideas out there looking at the plants, the paleobotany work that's been done up there. You take a look at a lot of that. And you can reconstruct that environment was like, the rainfall patterns were like, things like that. So it was probably overcast a lot, warmer, but not hot, cold in the winter, very long dark nights. And so these animals did have to deal with an environment that definitely was not the tropical, steamy sort of conditions you normally think about when talking about dinosaurs. Definitely not like conditions in Utah at the same time. And but yet here they were in great abundance. We find herds, bone beds full of these animals. So there were a lot of them. And it just kind of have to reset your thinking of what kind of conditions dinosaurs liked.
And do we have any evidence that those dinosaurs had any special adaptations for living in those conditions?
You know, that's a great question. That's a bunch of different questions wrapped into one right there. Yeah. I mean, you know, we find differences in these dinosaurs in the North Slope than you find in their closest relatives further south, even say northern Alberta, central Alberta, places like that. You're looking at this skull here right behind me. Something weird and freaky about it is, you know, for being a beaked ceratopsian, you know, parrot-beaked sort of animal, it doesn't have a parrot beak. It's got a round, smooth, contoured, curvy sort of beak, but it doesn't have a beak like the one behind you on over your shoulder.
Yeah, right there.
And but all of its relatives do, and that's not the only one. We have multiple examples of it. So that's just in that animal something odd. Is that an adaptation for living differently on the North Slope than they did down south? Who knows? Troodontids that lived up here, we find lots and lots of teeth of them, but they're twice as big as troodontid teeth of the same age down south. So okay, they were adapting, perhaps evolving and adapting to take advantage of perhaps a dark, dim conditions that we have up there, because they got whopping big eyes compared to some of the related, carnivorous dinosaurs. And so perhaps they were a little pre-adapted for an advantage. Who knows? So these are sorts of things we can speculate about. I'd love to be able to test them a bit better scientifically, but some of this, a lot of arm waving and creative thinking. But we study the anatomy of these animals enough, we can start making some more informed decisions about how they adapted to this weird environment.
And Jaelyn, so do we see anything similar with the mammals? You were telling me something earlier about body size.
Yeah. So you mean with the Alaskan mammals or with the Canadian Arctic?
Up to you, or both.
Okay. Well, I'd say we know a little bit more about the Canadian Arctic ones, probably. So the Canadian Arctic mammals, the first ones were actually described in the mid 70s by Mary Dawson, a colleague of mine who recently passed away in 2020. But Mary had recovered something else I didn't put out there, but people always love this: alligators in the Arctic, right? I mean, that just blows our minds, right? Alligators and giant tortoises and things. But in terms of the mammals, so we have done some. It is tough to, as Ron pointed out, it's difficult to test, right? To really test hypotheses concerning paleobiology. But we have done some tests. Specifically, what I've done is I've started going to geochemistry and looking at different kinds of isotopes, which can be used to not only get at climate, but it can also be used to get at behavior in some cases and in diet. Carbon isotopes, for example, can help you with diet. And what we can tell with some of these mammals in the Eocene Arctic, so 52 to 53 million years old, is we know the Coryphodons were eating a very different diet in the winter than the summer. In the summer, they're going for flowering plants based on the isotope signature that we find in their teeth. We think they're probably eating flowering plants, which makes sense. In the winter, they could be eating a variety of things based on the geochemical composition of the teeth. What it would suggest they might be eating would be things like tree bark, branches, potentially evergreens. And there are animals today that eat evergreens, conifer sorts of things, maybe even fungi. So what we can tell by the isotopes is we just know that Coryphodons had a very different diet in the winter than the summer. And what we can also do, and this was really a fun little experiment we did, is to look at the ranges of isotopes, specifically the oxygen and the carbon, and we could tell that our Coryphodons were staying up there all year round.
Oh.
The reason is because they have the same range in their isotope values as you find in trees in the Arctic, the trees that lived in the Eocene Arctic. And we're fairly certain the trees weren't migrating. And so we can go, okay, this range of isotope values suggests these animals were staying up there all year round. Otherwise, we would have gotten a much bigger range if they had been, a smaller range. I'm sorry, that we would have had a smaller range in isotope values if they had been migrating back and forth. So we do know they're staying up there. We do know they had a weird diet in the winter, although it's really hard to pinpoint diet on isotopes or anything else. And in terms of size, you asked me about size. We do know that some of the mammals in the Eocene Arctic were larger than their mid-latitude counterparts, including Coryphodon. And this is something people have referred to for modern mammals as Bergmann's rule. So we're getting some of the pieces of the puzzle filled in, but we got a long ways to go. And
so you're talking about the different diet in winter and summer made Keith that's watching ask about whether we think the same might have been true for dinosaurs in the Arctic. Do we have any info on that, Ron?
Yeah, actually, some similar sorts of isotopic studies have been done on some of these things, Pachyrhinosaurus and the Hadrosaurs and Monosaurs and their kin up there. And from those sorts of studies, similar to what Jaelyn was saying there, you can actually, some works have been done that show that these animals were eating in particular areas and not others. So for instance, an idea is, are these animals migrating? Are they going to going somewhere else in those nasty winter months when all the leaves are gone? And are they eating wood? Are they eating other things? And an idea has been put out there, were they going to the coast? The Arctic Ocean was to the north of them. So maybe they left the highlands and the swamps and such. Maybe they got to the coast and maybe they ate stuff that, sea grasses and algae and stuff that grew up there. But when you take a look at the isotope data, there is no marine signal in their tooth animal at all. So these animals were not going out eating things off the beach, evidently. And so that kind of throws that idea out the window. Instead, it looks like they were staying in the treed zones around the rivers and streams, or even further inland. They were eating food that was getting water that was washing off of the Brooks Range to the south of them, and the plants were soaking that up and the rainfall and stuff. They weren't going to the beach in the winter, evidently.
I have to ask you one question that one of our viewers has patiently been waiting for an answer all weekend, and I think you're the right person to answer it, Ron, which is Colin from San Jose wants to know if there are any sauropod dinosaurs from Alaska.
Not a single one known currently. Not a tooth, not a fragment, not a footprint even. And so, and this actually this is something I looked at really hard because, a couple of years ago, I wrote a paper about Alamosaurus from Texas down here. There's some people saying these things came from South America. Others say, no, they came from Europe, from Asia through Beringia. But there is not the slightest actual physical evidence of a sauropod anywhere in these rocks in Alaska.
That is so strange. Well, shifting back to something we talked about earlier, Jaelyn, people are really fascinated by your description of screenwashing and wanted to know more about that. And so BJ on YouTube wanted to know, how do you figure out what sites or rock layers to actually collect sediment from to screenwash?
That's an excellent question. Yeah, I mean, you're not going to do everything, right? You just can't. If you imagine, we could be busy for hundreds of years washing all the dirt out there. but what we do, especially in the Arctic regions, is usually what you do is and actually Colorado too. I do this in Colorado, same style. Is when we're out looking for fossils, if we find a site that produces even just bits of bone, bits and pieces of bone, it might not be anything special. I might not be able to identify them, but if I see them on the ground, there's a pretty good chance I'm going to take some of that back. I just might say, and particularly in an Arctic region where we just don't have as many fossils yet. The area has not been as explored as, say, Colorado, Wyoming, Utah, places like that. So if we find any evidence, like even a single little itty bitty fragment of bone, there's a really good chance I'm going to basically start scooping it up, putting it into a bucket, haul it back for washing, and screen wash, just even do a sample. When maybe we collect 3 or 4 buckets to do a sample and see what we get out of it. And the reason I say that is because the fossils that we've been finding on the North Slope of Alaska, at least with regard to the mammals, the dinosaurs are a different story, but with regard to the mammals, they're few and far between. They just really are. And so you might go through several buckets of sediment before you even find, a handful of fossils. And so anything is special, if that makes sense. And so generally what we'll do is we'll kind of zoom in on an area by noticing something about it that maybe it's one bone, a couple bones, whatever. We'll collect it, we'll run a sample, and if it looks good, if we find anything in there, we're probably going to haul back many, many more buckets for washing and sorting. As you can imagine, I mean, this is a really tedious job. Years ago, when some of my predecessors working in places like Wyoming were working the late Cretaceous, Bill Clemens, for example, they would go through, if you read their papers, they would go through tons of sediment to get a handful of teeth. Like just an unbelievable amount of dirt was being washed and sorted. I'd say at mid-latitudes, it's a different story. So certainly in the Eocene, very different story. You probably get, generally they're much more abundant. But working these Arctic regions, the way I've always treated them is that, anything is special, anything's going to be new almost that we find in the Canadian Arctic and on the North Slope, that you just, you take more chances, you wash a lot more dirt, sort a lot more to get those fossils. So I hope that helps a little bit.
Yeah, definitely. I have a follow-up question, which is you sort of mentioned the screen washing process itself, but also the sorting process. And Dusty on Facebook was wondering whether you pick out the fossils during the actual washing, or is that something that you do in sorting, and how do you do that?
Good question. You can. I will see people trying, we call it high grading, when they're washing, and they'll take a tweezer and they'll pull things out. I don't like to do that. And part of that is because if your fossils are wet, I notice when our jaws and little bones get wet, they can be delicate. And so to me, it's often better to let it dry out. And that's what we would do in the lab, is if we're screen washing, we actually have a special sink at the University of Colorado for screen washing. We will screen wash, then we will let it sit on a drying rack and dry it out for maybe 48 hours before we start sorting. And we just find that the fossils, once they're dry, they're not as delicate. They can handle a little more, versus if you pull them out wet, there's a good chance you might accidentally break it or crush it. Especially when you're dealing with mammals that, a single tooth is, like I said, it's about 1.5 millimeters long, the teeth, most of the teeth that I'm working with. So it's so easy if you were grabbing that to just, it's much easier to work at it under a microscope where you can see the tooth and you can very carefully, delicately pick it up with forceps, put it into a little vial and tag it and so forth, put a number on it. So I tend to recommend, particularly for sorting these little tiny guys, is to work at it under the scope. It's just going to be safer for the fossil.
And you've mentioned how super rare these mammal fossils are. Are there other types of small animals preserved in those screen wash concentrates?
Yeah, Ron may be able to comment on this. I know there are plenty of fish, for example, because we've been sending them up to a gentleman at the Tyrrell Museum in Alberta, Don up there. So there's certainly fish, baby dinosaur teeth, little itty bitty dinosaur teeth that are really competing with my mammals in terms of size. Small end.
Cool. Well, Ron, yeah, that's a great transition, because we have a number of questions sort of bouncing off the topic we talked about earlier, which is possible adaptations or specializations for living in the Arctic. And so Amy on YouTube wanted to know whether these dinosaurs living in the Arctic had feathers or something like that to help them survive. And there was a question from Dizzy on YouTube who wanted to know if they might have hibernated.
All right, so two questions there. Could they have had feathers? Possibly. It turns out we now know that a number of theropods, especially the carnivorous dinosaurs, had feathers, especially the smaller ones, the troodonids, dromaeosaurs, things like that. I mean, we have good fossils of those from Asia that preserve these things. There's just, yes, those ones almost certainly did. And, now the question is, when you have something a bit larger on the theropod side, something like, a Nanoxaurus, which is the tyrannosaur from up there, that's a pretty good size animal, but it's not a Tyrannosaurus size animal. It's kind of a pygmy tyrannosaur, a runt here. So what could this thing have potentially had feathers for insulation to survive in that environment? Maybe. Until we actually have the real evidence, I'm just waving my arms around. It's artistic license at that point. Some of the other groups of dinosaurs, there's less evidence for them to say have insulation or anything like that. So hadrosaurs or ceratopsians like Pachyrhinosaurus there, or the little baby duckbill dinosaurs like this one here that we get. I mean, this is a little animal. This isn't much big. We wouldn't have a skull much larger than a good-sized dog. Yet it's living in an environment that gets too freezing and below during those long winter nights. How do they stay alive up there? Good question, which goes to the second question you asked, could they have hibernated? We do sections of the bones on these animals, and it does turn out that some of them have kind of almost growth rings like trees, so that they grew faster at certain points of the year and slowed down at other times of the year. They grew fast when they were young and then slowed down when they became larger and adults. As far as hibernating though, that's a bit more of a question. And so, people are still wrestling with this one. Did they just sort of slow down? Are those rings in the bones because, man, food became scarce, man? We had to slow down growth because we just didn't have anything to eat. Or was it something else? And so those are just some of the questions that we're hoping to answer with continuing to study these things.
And Jaelyn, we know modern mammals hibernate, some of them. Do you think any of your Eocene Arctic ones did?
Yeah, it's a good question. No, we don't. We actually don't think that they were hibernating per se. But I'd also say it's really difficult to prove that one way or the other. I know at least with something like Coryphodon, we're certain he was eating something in the winter because he's just got crazy isotope signatures in the winter. So they're eating, but they're so that would suggest they're not hibernating. We would not predict that they're hibernating. And then other things, certainly smaller mammals. This has been suggested for the mammals from the North Slope, for example. They're all tiny. So maybe you're not hibernating per se, but you could be living underground. And we know that, it doesn't take much to, you don't have to be that far underground to essentially be insulated fairly well during the winter. So there could be things going on in that end of things, but I think, at least for the Eocene mammals, I would say I don't think there's evidence at this stage that they were hibernating, but I'm not sure there's as much of a reason to. If you've got a nice, balmy Eocene, height of global warming since those dinosaurs went out, non-avian dinosaurs, then people have likened the Arctic at that time to maybe be like a cloud forest. It would have been a dark cloud forest, but nevertheless, a lot of the modelers, the climate modelers, would put a fairly thick layer of clouds in that winter. And that's a way to keep your heat and your moisture in. And so if you're not freezing, you're not, and you're able to eat just an unusual diet perhaps in the winter, I'm not sure you have to hibernate. I think that would be the question I would ask is we probably maybe don't need to.
Yeah. So we've got a couple additional questions about what other types of animals were in these ecosystems that both of you have been talking about. So Jaelyn, you had mentioned, in addition to the mammals in the Eocene, there were alligators. And Kim on YouTube wanted to know whether there were snakes and turtles as well.
Awesome. Yes, there were turtles everywhere. That's the really cool thing. I think we've got, and this is the work of Howard Hutchison, who's just an amazing turtle expert extraordinaire. And I think Howard's identified 9 or 10 different families of turtle in the Canadian Arctic, ranging from pond turtles, something that, like a red-eared slider type thing, although we can't say it's that same family, to tortoises, giant tortoises, not unlike, or certainly belonging to the same genus as what you see in the Galapagos Islands today. So you've got big land tortoises, you've got soft-shell turtles, you've got emidids or the pond turtles, and a variety of other guys, the inosterines, lots of different kinds of turtles. You've got an alligatorid, a boa snake, a giant salamander called Piceuropodon, a varanid lizard. And I haven't talked at all about birds. We have birds too, including Gastornis, the big flightless bird. We have paleobotanists have found footprints in the fossil leaf beds. And then we have a few bones that we described a few years ago of Gastornis. And then there's some aquatic birds as well. You find bits and pieces of them. So it's a diverse fauna, and it's not unlike in critters to faunas of the same age that you find in Wyoming, Colorado, places like that, Utah.
Well, it sounds like, man, as long as we didn't get eaten, going back to the Eocene of the Canadian Arctic would be pretty cool.
Yes.
So similarly for Ron, William here in Utah was wanting to know more about the types of dinosaurs in the Arctic. So we mentioned there's no sauropods, but there are tyrannosaurs and horned dinosaurs. What else is there?
Besides our Nanosaurus we have running around on the North Slope and Pachyrhinosaurus here, we've got at least 2 different kinds of Hadrosaurs. Again, like these little guys here, we've got lots and lots of these little animals here. It's a Monosaurus. Sometimes other people have called them other names for different reasons, but we got a lot of these, and it turns out we have at least one sort of Lambeosaurine up here in the same beds we found. So these beds have essentially bones of at least 2 different groups of hadrosaurs up there. There is at least one skull in Alaska of an armored dinosaur. That was something like Edmontonia or something like that, an ankylosaur. Pachycephalosaurs, part of a skull of one of those that washed out of a cliff up there long ago. And I think that one was named Alaskacephaly by somebody. I have to look that one up. And birds. We don't have much in the way of body fossils, but some of these places that have been looked at, you find tracks of things like that. So, and that's also, there's more than one slice of time represented in the North Slope rocks. The Pachyrhinosaurus and their friends here are around 70, 68 million years in age. But if you go to the far western edge of the North Slope, you're going down section, you're going into older rocks that are more like late Cretaceous in age, and even potentially going into the late early Cretaceous. So you're talking, 95 million year old rocks there versus 70 million here. So, so you get different assemblages of different kinds of animals as you go through time as well. So there's much greater diversity of dinosaurs were there, undoubtedly. And then of course, a bunch of little theropods and other little animals that are pretty much known from Troodonids, Dromaeosaurids, little plant eaters, ornithopods like Parksosaurus sort of things, and an assemblage like that. And then a few bits and pieces of non-dinosaur things. But you know what? Unlike Jaelyn's Eocene site, no crocs, no turtles.
Oh,
Big zero on the fossil record. So you go most places, you find croc teeth everywhere, right? You find turtle shell fragments everywhere. I'm sure you've seen this yourself, Randy. Nothing. So whatever the conditions were in the late Cretaceous of the Arctic Circle, they're a lot different than they were in the Eocene in the Canadian Arctic.
Mm-hmm.
Maybe you briefly mentioned it in your answer, but I missed it. But Dusty was wondering whether you found eggs or nests of dinosaurs.
I don't, and not that I know of. We, we think these animals, we now have evidence these animals were probably living up here in the Arctic year round. I mean, this little guy here, that little jaw isn't much bigger than a medium-sized dog, and mom and dad would have a lower jaw this long or whatever. So these animals were too small to migrate, so they probably lived up there year round. We just recently described a tiny fragment of a jaw of a meat-eating dinosaur from Piedomys Point, actually, where mammal fossils up there. That is a juvenile dromaeosaur, one of these little feathered little guys running around up there, but it's little bitty. The whole jaw, if we had the whole jaw, would only be about that long. Mom and dad would be jaws like that. So you think these animals were living and breeding and nesting? Probably, but we just don't have nests and eggs yet. So again, we have to extrapolate from the few fragments we have.
Gotcha. And following up on one of the animals you talked about, Jaelyn, Wes on YouTube was wondering how big Gastornis was. You said it was a big flightless bird. So.
I mean, these are things that would be as taller than a human. I think taller than a human, most of them. The footprints, and this is what I've seen in the Arctic, are, probably my head kind of thing. They're good sized footprints. So you're dealing with a big bird. When you see reconstructions of Gastornis, they like to show them attacking little horses. And I work on those little horses, so it makes me mad. But part of the reasons it makes me mad is because the research these days suggests that Gastornis, the things that had to worry about Gastornis were the plants, not animals. Gastornis these days, based on the bones, basically look at the bones in the skull and the jaw, suggest it was actually a plant eater not a little horse eater. So, so all those pictures reconstructing this guy eating a horse or horses, usually a herd of little tiny horses, are probably not correct. So, so yeah, so think big bird, bigger than me for sure, and taller certainly, and probably chomping down on plants. If I were a plant in the Arctic, I might be worried.
Well, we've got just 5 minutes left, and there are just so many great questions coming in. It's hard to keep up. Unfortunately, we won't be able to get to all of them, but I do want to ask one of both of you, and let me just make sure I get correct the name of the person who asked it. Yeah, Raisa on YouTube was wondering, or we'll start with you, Jaelyn, whether you have ever had the chance to name and describe a new species.
I have. I've gotten to name a number of new species, starting with my PhD back in the late 90s. I got to name several new species of mammal from Wyoming, and they were mammals that lived right after the dinosaurs went extinct, in the first million years after the dinosaurs went extinct. And it is so exciting. I think it's super fun. We've named a number of new species from the Canadian Arctic, including the Arctic tapir, which is named Tuleodonta. It literally means northernmost tapir. And then we named a little tiny marsupial mammal from the North Slope of Alaska. It would have been an opossum-like mammal about the size of a house mouse. We named that about a year ago, and we called it Unuakamis, using the Inupiat language, which would be the people who occupied that region and still do. Of the North Slope, and literally Unuakamis means night mouse, and we named it that because we thought it would be it was living there probably year round, so certainly during the winter it would have felt like a night mouse. So yeah, so I have, and it's super fun. I think there's a something special to trying to come up with a name that you think fits the animal and honors it. So lots of fun.
And Ron, how about you? Have you had the chance to name new species?
Yes, I have. Kind of a broad range of different things. Back in grad school, named a early Jurassic crocodilian from Arizona. Named a bird here from Dallas-Fort Worth area back about a decade ago, fossil bird from the Cretaceous. And then helped name a couple of these dinosaurs from the North Slope, Pachyrhinosaurus perorum there behind me, and Nanoxaurus hoaglandii, both while here in Dallas. So yeah, it is fun. I mean, it's not like we keep a running tally or score. Whoever names the most doesn't get the prize at the end. But it is neat because every one of those represents moving the ball forward in scientific knowledge, understanding the diversity of life on this planet, and help filling it out more. And I think secretly everybody hopes that every time you crack open another little thing or you screen wash another pile of sediment, that there's going to be something there that's going to send off a whole new line of discovery and understanding of the evolution of life. It's fun.
Oh, awesome. Well, we have just about a minute left, and so it's really hard to choose just one last question to ask both of you. But I guess I'll go with this one from Facebook, which is whether the predators in these ecosystems would have been better adapted to hunt in the darkness than in other places. I know, Ron, you had mentioned something about big eyes, so why don't you answer first and then we'll go to Jaelyn.
Yeah, some of the evidence, the proportions of who you see and what, it does look like these animals were adapting to this very unusual environment, changing body size or whatever. But with regard to those troodontids, their numerical advantage over the other theropods, we find up there just suggests that they had something that let them outnumber everybody else. I mean, you look at their anatomy, big eyes, covered with feathers, whatever, who knows, maybe they had better night vision than everybody else, maybe.
And how about the mammals, Jaelyn?
For the Eocene Arctic, we do have predator mammals up there. We have true carnivorans, a group called the myocoids, which would have been squirrel-sized things. So they were not taking down coryphodons, I can tell you that. But then we also had bigger carnivores like mesonychids and things, and creodonts, which is kind of a primitive carnivorous group, its own thing compared to, say, the carnivorans like the felids and canids and things like that, which were later. We don't have those guys up there. We can't really say much in terms of if they were adapted to, say, darkness or things like that. And the reason is because the Canadian Arctic fossils are really fragmentary. And so typically what you're finding are teeth. You might get part of a jaw and a tooth or two, but we don't have any skulls or, there is a partial skull of a Cryphodon, and that's about it. But we don't have any of the carnivores. We don't have postcranial elements that we've been able to tie, or body parts that we've been able to tie to a skull or teeth of a carnivore, things like that. So we just don't really have enough complete fossils in the Canadian Arctic to be able to say what the carnivores may or may not have been adapted to. We do know, so Cryphodon is not a carnivore, it's an herbivore, but we do know Cryphodon must have been well adapted to the north, because we find it in Europe, Asia, and North America all at the same time. And the hypothesis is that it was cruising around these between these continents over northern high latitude land bridges like Thuringia into Asia, and then what's called the Tulian land bridge into Europe, that was kind of a short-lived land bridge in the early Eocene. So we know certain animals must have been adapted because we find them on multiple continents in the north and in the Arctic as well. We're just not getting enough of the fossil evidence or complete enough fossils to be able to say, yes, this has big orbits or whatever that might have allowed it to operate a little better in the north.
Well, that's a great way to end, to encourage future paleontologists to get out there and find more fossils to help answer some of these mysteries. I'm sad to say that's all we have time for at the moment. I want to say a huge thanks to our expert paleontologists, Dr. Jaelyn Eberle and Dr. Ron Tykoski. And a huge thanks to all of you viewers who have tuned in for this, our 5th of 6 Polar DinoFest live conversations this weekend. Our final live stream will air today at 5 p.m. Mountain Time with our 2nd Polar DinoFest keynote speaker, Dr. Peter Makovic. Remember that this weekend's live conversations kick off 10 weeks of Polar DinoFest exploration with a new polar dinosaur video from one of our guest paleontologists being released each Friday at 10 a.m. Mountain between now and April 2nd. See all of the recorded live stream conversations and watch our full Polar DinoFest videos when they become available on our website at nhmu.utah.edu/DinoFest. Finally, don't forget that the inspiration for this year's theme, our current special exhibit, Antarctic Dinosaurs, is open at the Natural History Museum of Utah through April 4th. Be sure to supplement your online Polar DinoFest experience with an in-person visit to the exhibit by booking your tickets in advance online. Polar DinoFest has been made possible by the Alternative Visions Fund, the Utah Legislature, and the Utah Division of Arts and Museums. Many thanks to these sponsors for helping us bring you Polar DinoFest online. Thanks for tuning in, and we hope to see you back here again at 5 p.m. for our keynote conversation. Thank you so much, Ron and Jaelyn, and I hope you have a great evening.
Thank you, it was fun.
Every year, NHMU's DinoFest brings you face-to-face with the world's top paleontologists and their incredible discoveries. Now in its 5th year, DinoFest is going online with 10 weeks of virtual exploration of the frozen world of polar dinosaurs. From the Alaskan North Slope to Antarctica, dinosaurs are found on all 7 continents. But how did they survive at the extreme ends of the Earth? Join us online each week starting January 23rd as we introduce a different paleontologist whose research has helped uncover a thriving polar world far different than what we know today. Polar DinoFest starts online January 23rd and continues through the run of our special exhibit, Antarctic Dinosaurs, open through April 4th. Don't miss it.